And good afternoon, everyone. Dwayne here, Radical of Math. Commentary 2. Calculators are a symbol of a larger issue. So, full disclosure, I own 3 calculators. I have the current calculator that is favored by the majority of teachers and professors out there, the TI 84 plus CE colored calculator, rechargeable, but don't lose the cable. I have the Casio FX991ES Plus Second Edition, a non-graphical powerhouse. Very good calculator, also inexpensive. And then lastly, Old Reliable. This is one that when I did my undergrad back in the day, and actually helped me do it, TI 83 Plus. Still works, 4 AAA batteries. But the thing is that I was able to use these calculators because my instructors had demanded mastery before I could use those calculators. And one of the big issues is that many school curriculums are using calculators at a very early age. Some of them are using it as low as the 2nd grade. They have this giant suitcase. Here's these 4 functions, practically indestructible, solar-powered calculators, and they're telling students, go do math with this. This is what math is. That's not what math is. Math is the language of number. And our diminishing numeracy is now a significant issue in this world that is very tech-oriented. You have AI, quantum computing, fusion, thorium reactors, new breakthroughs in materials science, just to name a few. So I'm going to say something that's radical, how appropriate. Calculators should not be used until at least calculus. Because here's the thing. If you really understand learning, learning is a 4-step process. You discover the subject, gain some exposure. Then you start experimenting with that subject. You start learning from your errors. You start refining the technique to gain mastery. And you must have mastery before you can have application. Then you have what I call the comprehension and auditing process. Here's where models should live at in terms of, hey, we're now going to use a math model using this learned concept you just did. We're now going to apply it to a life situation to make it pertinent. And then at the very top rung, the rigor and competency of the I know I got this. What many curriculums are doing, however, is they're trying to put the models before you have the mastery. And that is wrong. How can a student ever successfully apply a method or procedure if they don't understand the inner workings of it? So I got some notes over here, and I'm just going to reference a few of them in this commentary. The point is, we're in the mid-20s as a country in the United States in the PISA standings. But yet a lot of people come here to university. Why? It's a good question. And what's happening is kind of as a side effect, curriculas are doing a process I refer to as nesting, where a concept is introduced at a lower grade, and then it's reintroduced and furthered at a higher grade. especially in the elementary and junior high, you see this staircase effect. And now what happens is, and I think you often see it with decimals and fractions early on in elementary school, is these students haven't seen this in potentially a year, and they're like, we don't know how to do this. This is the wrong strategy. You have not demonstrated mastery before application. It's great to say, hey, Mom gave me 3/4 of a pizza and I ate 2/3 of it. How much pizza did I actually eat? But to get to that, you got to build them up, and that's simply not happening effectively. The National Council of Teachers of Mathematics comment that mastery should be the primary function of math, while having needed conceptual understanding. Now, there are some things in the NCTM that I openly question of why would you say this is a policy? But when it comes to statement of beliefs, they're pretty dead on. And right now, we as a country in the United States are grossly ineffective in general when it comes to mathematics education, especially those individuals getting ready to enter college, which is the main thrust of my comments today, or your technician / engineer / STEM. Now, contrary to the NCTM's policy of people should avoid using gifted, honor, above average, high, below average, etc., which frankly flies in the face of common sense and good order, I, for one, would want to have tracks, especially now that I am a parent by proxy. I have a 15-year-old who is about to become a sophomore. She just got her permit, by the way. Watch out, Kentucky. That's all I'm going to say. And I am seeing what she is learning. And it makes me very aware of what's being taught and what's not being taught, and especially how and why in terms of methodology. You need labels and tracks so that you can funnel students to their most effective educational outcomes. It all comes back to mastery. If you have a general student that, okay, they're really good with their hands, but they're not exactly book smart, you have a track for them. You have a track for those who are going to specialize, and then you have a track that is collegiate preparatory ready. This is not hard. And the fact that the NCTM was like, no, don't do that. Don't put labels. Don't do this. It impacts student outcomes. No, what impacts student outcomes the most, and this comes from your own writing, is the inability of the student to persevere. Why will they not persevere? It's very simple. You're rushing them to do things that they yet not understand because you don't give them enough problems, you don't give them enough foundation, and therefore the time they need to experiment and refine technique, that's the second stage of learning in my mind, is not being done correctly. This shift of we need to model everything because they need to know how to apply what they read. They're never going to be successful at that unless you give them the time to discover, be exposed. Then they need to experiment and be refined in technique, as in give them enough problems in a problem set so they know what they're doing. Then and only then can they really apply comprehension and audit what they understand through doing modeling problems, word problems, etc., so that at the very end, they actually have rigor and competency in the topic that's discussed. Where you see this first, where it fails often with students, is fractions, decimals, And it really shows up in percent, even though percent should be easier. It's not. And that is because a lot of curriculas go for breadth instead of depth, which I believe is wrong in the 21st century. You don't need to cover 15 things gradually. If you can cover 10 with sufficient depth so that student goes, hey, I know how to do these things. That solves the nesting problem, where curriculas will introduce a topic in a lower grade, and then in the following grade, they'll reintroduce it and then improve upon it. You're wasting the student's time. Once again, you often see this fractions, decimals, percent in the primary ages. But when you get to high school, you really see a radical breaking out where it's a fracturing, where you have students in Algebra 2 that they struggle to deal with lines, which is a linear function that you see in pre-algebra and Algebra 1. And this is a very common problem. Insufficient foundations equal insufficient mastery, which means ineffective application. This must change. It must change very quickly. Calculators are being asked to be the surrogates of teachers, of diligent practice, and of gaining mastery. That is not what a calculator is supposed to do. The calculator is a tool to expedite the process of calculation. Focus needs to shift back to mastery. It's that simple. You got to have rigor. Mastery is a form of rigor. And frankly, a lot of school districts are way too soft, especially in high school, because for college-bound students, it's a shell game. They got to have all the extracurriculars. They want to do all the things of high school with clubs and sports and whatnot. And, you know, we're trying to get the perfect 4.0 GPA and all that. And they get to college, and a lot of these students can't even read a book. The thing that hasn't really been disclosed a lot is a lot of these students get into a Calculus 1 course, and once they get into Calc 2, specifically integration, they're bombing it. Because they can fake it in Calc 1, but they get found out in Calc 2. And folks, we have failed them. Mathematics is a language you have to do every day. It's the language of number. That requires rigor, mastery, and diligence. Those are in very short supply for a lot of students because teachers can't be bothered in a lot of cases because they're either overworked, underappreciated, or the bureaucracy that runs that school system, frankly, doesn't know their head from their backside. And the real world is demanding a very specific set of skills. Now, the National Council of Teachers Mathematics, NCTM for short, have a policy paper right now. A matter of fact, I happen to have it on my work desk. This is an actual policy paper called The Intersection of Culture and Mathematics. There it is. This is on their website. And here is their position. Mathematics is a human endeavor and creative pursuit to understand and actively engage in our world. Could not agree with that anymore. 2 thumbs up. To create humanizing experiences and maximize learning in the mathematics classroom, educators must regularly and intentionally integrate culturally centered mathematics in each and every one of our PK to 12 mathematics classrooms. NCTM mathematics is cultural neutral, race neutral, gender neutral, because mathematics is the queen of the sciences. Mathematics is the language of science. And one of the premise that's asserted in this paper, and I'm going to read this statement out to you because I was just flabbergasted by this statement. Let me see if I can find it. It is important to learn and challenge how school mathematics reinforces the myth that only Europeans did mathematics. This is cited from Gutierrez writing in 2017. NCTM, did you look at the root word algebra and realize it comes from the Arabic language? NCTM, did you look at a standard Algebra 2 honors curriculum and find something called the Chinese remainder theorem? NCTM, look down when you start teaching time. It's based on sexagesimal notation from the Babylonians, who were not Europeans. Crap like this is why we are falling behind in mathematics in the United States. The base premise they even say in this, and I circled it, all learning is social. It's written in this policy. No, it's not. All learning is relative to the environment that the pupil is in. Furthermore, this paper, one of the things that it espouses is that culture and mathematics, under the premise of inclusivity, should be tailored to the demographic and/or region that it's taught in. So that means that if a very technical person here in Simpson County, Kentucky, wanted to do high-level math, because of this paper, that person wouldn't be able to do it because we're a rural county of maybe 16 to 18,000 people, and we have agriculture everywhere here in Simpson County. We're like food independent here. We grow almost everything. We need to import some citrus, but otherwise we do pretty good here. Likewise, you're saying that a Caucasian in the LA school district out in California, because most of the people there are Spanish speaking, that by this definition, a suppression of the significant contributions of the Mayans to mathematics should not be broached. Or flip the tide, if a Latin student is in Ames, Iowa, that they should be catered to instead of they should not be catered to, they should not be catered to because the primary demographic is Caucasian. Remember, you're saying inclusive, that means everybody. So what are you suppressing? Don't suppress math. Math is a beautiful subject. Math is truth. In this paper, smacks of common sense. I'm even having a hard time trying to figure out what's inclusive and what's not, because it's math. That's the beauty of it. It doesn't care who you are. If you have the goods to do it, like Sophie Germain, for example, do the thing. In summary, for this paper, mastery doesn't care about culture. Culture is always in flux. Like right now it's TikTok. Before it was Instagram. Before it was Facebook. Before it was AOL. Some of you are going to like, oh dear God, AOL. Yeah, I know. I'm there with you. That's part of the culture. Culture is always changing. But mastery is always fundamental. Mastery doesn't change. That's the beauty of math. And so the thing that I want to employ is calculators tying into this merely reinforce the fallacious argument that mathematics is a means to an end. It's not. Mathematics teaches you critical thinking. We're going to have rigor. We have to reduce our reliance on multiple choice tests. We need more free response type questions, because that's how students can translate the experimentation refinement stage to the comprehension and audit stage. If they can make an argument and say, the reason why this value is a minimum is, you're preparing them for a better life because they can think. Mathematics is a gateway of thinking. It's a gateway of reflection. And we don't do a very good job of that here in the States. So how do you gain mastery? How do you gain mastery? So I wrote a few things down. The first thing is, no calculators. I would not even consider using them until calculus. I don't think you really need it. And pre-calculus down, because if you understand the concept, if you understand the method, if you understand how to explain yourself, you're 85% fluent. And the thing that often is bypassed with calculator usage is accuracy and precision. They're two different concepts. So you don't need calculators. The next thing is, get off of the electronics. Grab yourself some paper. Grab yourself some pencils or pens, something to write with, and an eraser. Speaking of, right now I'm test driving some new pencils. I have a Mitsubishi 2B 4563 pencil, very nice pencil. I have an Apsara Extra Black, as I just dropped the pencil there. And of course, I have my Musgraves. I'm using the Harvest. Really love the Harvest number 2. But get yourself one of these. Get yourself some paper. Why are you typing every single thing? Writing helps generate mastery. There's scientific studies on this. And I practice what I preach. Let me show you. I did this yesterday. Doing math revision, I said, you know what? My implicit differentiation is a little rusty. Let me do some problems from the 12th edition of Calculus by Larson. I think Edwards is on that. I'll check that afterwards. But it's the textbook that Western Kentucky University uses, and so I'm using it too. There you go. There's some writing. I still got the giant newsprint pad. I got 500 sheets inbound this week. But I'm doing pencils, and I'm doing paper and erasers. And my understanding is not only reaffirmed, in some areas I go, oh, I forgot how to do that. It's being increased. So get yourself some good old-fashioned paper, pencil. Get off of the computer because of the distraction that it causes. And really hone in on procedure and method. We are not good in the method department at all, because the calculator circumvents that. And it really shows, I think in algebra, you really see that. You're like, how did you get from here to here? And they're like, they don't know. They're blank-faced. So, proper length of time and type of problems. Problem sets in textbooks, if you look way over there, right there, I have some textbooks and all that. A lot of your Common Core stuff kind of did like a 25, 50%, where the 50% being the highest level was They were trying to get you into modeling as fast as possible. I don't agree with that. You must develop mastery. And I advocate a 40% discovery and refinement phase, a 30% refinement, experimentation, beginning to gain comprehension phase. Then in that competency and rigor phase, the last 30%, that's where you put in your models. That's where you get the how and why. And now that student locks in and goes, hey, I got this. I have, and I think part of what's driving this is the standardized testing. The SAT should not be used as a STEM major eligible entrance. The math is poor. You're only doing words. It doesn't demonstrate enough critical thinking. It doesn't demonstrate enough overall knowledge like the ACT. You go overseas with the it's in Korea, they call it the CSAT, what is it, the Songyung, I think is the name of it. China's infamous exam, the Gaokao. You have A and O levels and GCSEs in the UK. And, France has the BAC, the baccalaureate exam. Germans have their exam and so forth. The rigor is much higher than our exams in the United States. There's almost a regression to the mean when it comes to exams here in the States. And that needs to be fixed. And what I would advocate is if you are a non-STEM major going to college, the SAT is fine. But if you're going into STEM, the ACT. And if you know your subject, you should take a subject test to demonstrate proficiency in that subject. Because here's the hard truth. Okay, you take advanced placement AB, and students are doing this. They're taking AB calculus junior year, BC calculus senior year. In advanced placement, they said point blank, it was never intended to be that. It was one calculus course, not two, for the high school student. You need to strengthen the curriculum. Contrary to the NCTM, yes, calculus must be the terminal end goal of a K through 12 math curriculum. Full stop. Full stop. And I'm going to go a step further. You need to accelerate that so that you can get students into calculus 3 and discrete math in linear algebra, as in you need more math, not less, because that's the way of the world. Realize this device we're talking on the iPhone, the computers and all that, AI and things thereof, you need a lot of linear algebra and discrete math to make it work. Students need exposure to that as soon as possible. As soon as possible. Strengthen, not dilute the math content. Specifically, pre-calculus needs a full-blown rework. Frankly, the AP pre-calculus course is a scam. It's garbage. It's hot garbage. It's repackaged college algebra. We need a revolution. We need another Sputnik moment. We need another, oh crap, we need to get our butts in gear, like in the late 50s. Because in 57, when Sputnik happened, the curricula, if you were to look at curriculas in 55, 56, 57, and then look at 58, 59, 60, radical change. Because this nation must compete. And there are a lot of smart people in the world, and they're not here in the United States. Trust me on that. So in close, there's a lot of work to do. Not only do I hold state educators responsible, I hold the NCTM responsible, I hold the MAA, Mathematics Association of America, responsible. By their own words, the NCTM say, quote, computational skills and number concepts are essential components. Their words, not mine. And they also acknowledge the widespread impact of technology, and they advocate its use to increase understanding. You're going to need to be very jurisprudent on that, because what's happening is it's becoming a surrogate, becomes a crutch. And you got to have, the last thing I wrote in my notes is conceptual understandings of procedural fluency or equivalence. They have to be equivalent. As the NCTM say, a curriculum is more than a collection of activities. So, pretty long commentary, I know. But if you really want to learn mathematics or learn anything, you not only need just exposure, you got to do the thing. I hope my example where you see, hey, he's doing math revision almost daily, and I do mean almost daily. That inspires you, whether it's in math or somewhere else. You know what? I need to spend some time with that. I need to continue to master the skill or skills I need to master. So, I hope this video finds you well. As always, take care of yourselves, take care of one another. God bless. We'll see you next time. Bye for now.